Yeah, like an astronaut, like a crazy astronaut in space.
Series.
Who's the one that writes the? Is it James Conley? Is that his name? One that does like all the political murder books.
Oh, I don't know him. Is this like
Sound like the expert one.
House of Cards kind of stuff, or
Not
not that I've seen House of Cards, but I'm given to
it's
understand
more
it.
I think it's more like an FBI agent goes rogue.
Yeah, interesting.
Sounded in a very sexual manner. You said that.
It's actually an erotic thriller.
A young woman's journey from Milan to Minsk. This is all in the recording, by the way.
What?
Oh, just
Erotic
our.
thrillers.
We were discussing. Hey,
Gonna have to catch up this time.
just as the erotic thrillers came into the discussion, Rafa strolls in.
Talk about erotic thrillers.
Yeah, well, you came in with cookies, which that's a thriller of some sort. It's a sensory thriller. I usually actually post the programming slides unedited, but I might edit this one. Yeah, so dig in, cookie yourself up. Okay, so I will actually pull up what we did last time, even though we're not going to do too much of that right away.
No.
Sorry, guys. If anybody wants some iced coffee from my office or a Diet Pepsi, I can hook you up.
Thanks for the cookies.
Okay. So PyCharm is up. Okay. So yeah, once we cookie ourselves.
Macadamia nuts and banana and something.
Oh yeah. Any interesting weird cookies today?
They were all the same selection.
Okay.
There's like a banana nut and a macadamia nut.
Wait. A what?
No, not banana nut. Banana something. The one with the white frosting.
I think there is a nut. I think it's banana walnut, right?
So we say banana.
Oh, so yeah.
We say banana. Banana.
Do that.
All right.
I feel like I'm lost between all these.
Oh, that's the weird kind of oatmeal one that does have chocolate chips.
Yeah, there's two oatmeal raisins as well.
And there's their oatmeal raisins.
Someone said they like those.
That's what mine is. I used to say
That's the banana
I think we should go the chocolate explosion like I usually do.
one. Yeah.
Okay.
It's that.
Fresh batch. Kind of warm still.
Yeah,
Okay. So this is where we left off last time. I think we get through, if people can help me recall from 2 weeks ago, I think we got through kind of discussing all of what this does, right? If I recall correctly, we kind of left what that percent thing does kind of towards the end, and that was unexplained. So what the line numbers always disappear. Hang on. So let's view our line numbers again. Okay. So this stuff in line 19, I think that was the newest stuff, right? If I am remembering correctly. And also, did we talk about the for loop very much last time? Or was that kind of new too?
We talked about the range thing because it
Oh, that's right. We spent a long time talking about the range thing. All right, I'm remembering this now. But I think this was pretty new. Do people remember what that percent sign means? I should say it that way, I guess.
I don't think we
didn't discuss exactly.
Okay. All right. So let's actually, then step through this. Sorry, I don't remember. I looked at this beforehand, but I was trying to do it during the talk, so I couldn't tell exactly what we were saying during this time. So let's run the debugger here. Just make sure everyone's still on the same page, and then we'll kind of do some paper exercises. All right. So remember we set a breakpoint here at line 14. That means everything above here already got run. So at this point in the script, we have a variable named added cookies, which is 3. We have a variable called company, which is a string. That's the cookie company. Variable called cookies, which is an integer, which currently has the value 27. And a variable called counter, or cooter, which is currently 18, right? So now we can step over this. That's just going to print I'm going to eat cookies now. we have a while loop. So what's that? So what's going to happen after line 15, or what's going to happen on line 15? Come on. Well, is cookies greater than 0 right now?
True.
Okay, that's true. So if that condition is true, where do we go?
So we can go to line 16.
Yep. So we go to line 16. You know, we go into the while like chunk of code. If the condition's true, which it is, it's going to print I'm eating a cookie. Cookies will get cookies minus 1, so that will become 26, down from 27. So line 19 has an if condition, right? So we're going to test if cookies %12 is equal to 0. Let's see if it is. Well, it looks like it wasn't because it didn't do line 20, right? So let's go again. So it's going to say I'm eating a cookie, cookies minus 1. Oh, look, it didn't. It once again did not go into line 20. All right. So this time, let's see, line 19, if cookies %12 equals 0. All right. So it did go into line 20. So someone who does not already know what the percent sign means in Python or JavaScript or C or lots of other languages, what do we think that, so what is true of 24 and 12 that is not true of 25 and 12, 26 and 12, or 27 and 12?
I think I'm gonna guess that since it's a double equal sign, you're trying to evaluate if something is like divisible by 12 and has like no leftover or no remainder.
Okay, exactly, yeah. So the percent sign is testing the remainder of cookies divided by 12. So did we only stick this in at the end last time and not really talk about what it is? Is that where we left off? All right. So that was my coffee that I just took from your desk, right? Not yours. Okay. Oh, that's right. You didn't get any coffee because I got the last cup. Sorry. I didn't know it was going to be the last cup when I took it. All right. So if we do this in Python here, so if we had like, let's say 25% sign 12, it tells us 1, 26% sign 12, 2, 24, doesn't type, percent sign 12. That gives us 0, 36% sign 12. That gives us 0, 37% sign 12. That gives us 1. And actually, we could even do this with that little for loop, just to remind you how for loops work. So for, let's just call them I. For I in range 50, print I percent sign 12. All right, so that did that a whole lot real quick. So what happened there in that little 2 lines of code? So what does that for I in range 50 do?
Counts everything 0 to 49 and
Okay.
divided by 12.
Right. So the for statement, it means like range 50 is going to be the number 0 through 49. The for I in range 50 means that we're going to do this like 50 times, where each time like I is first 0, then it's 1, then it's 2, then it's 3, then it's 4, then it's 5, up through 49, right? And then that line under the for statement is going to do I percent sign 12, whatever that means, and print it out, right? So what you can see is that just goes 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 0 through 11, 0 through 11, 0 through 11, 0, 1, right? So the last number that I am, is 49, right? If it goes in the range of 50 numbers, 0 through 49, 49 divided by 12 in remainder terms, right? Like, so 12 goes into 49 4 times with a remainder of 1, right? So the last thing we print out is a 1. Does that kind of make sense to everybody? I can't remember if we're going too fast or too slow relative to where we stopped last
If
time.
you want to, like, say you have 48 and you want to see the total answer 48 divided by 12 in like whole number and then the remainder, would you have to do those separately, or can you just show?
Yeah, you just have to do 49 divided by 12.
You would have to do it separately.
I mean, in a sense. I mean, you could always say something like
Yeah, I was just wondering.
Print.
Like one function.
49 divided by 12 is, you know,
Yeah,
how do we do this?
with the remainder off.
With a comma, right?
Yeah.
49 divided by 12, remainder 49, percent sign 12.
Right.
Right. So yeah, but there's no one. I mean, you could write a little function. We haven't gotten to functions yet in this iteration of the
It
course.
would be useful in like calculations because I know we've used division and the remainder for finding specific values. I don't know if it would ever be.
Yeah, I mean, if you had a mathematical operator that, I mean, there's a couple ways you could do it, right? I mean, you could also do 49.0 divided by 12. That, in a sense, gives you,
The remainder.
I mean, that's what a decimal is, right? Is the is a whole number with a remainder, in a sense. But you know, if you had a mathematical operator that gave you both the whole number division and the remainder, you know, that would have to return two values, right? But you could do that with like a function, which we haven't really gotten to yet in this version of the course. But yeah, like most, you know, arithmetic operators, you know, take two things and return one thing. So yeah. Okay. So everybody remember how the for statement works, and everybody clear on how that percent sign works? Are there any questions there before we go on to the paper demonstration, or are people feeling all right? Do people feel, yeah.
What's the difference between a while thing and an if function?
Okay. That's a good question. What's the answer?
Seems like it makes more sense to use a while statement in like something where you want to do greater than or less than. I guess you could do it with if too.
No,
so
you can do that with
it.
if too.
Yeah, it's no problem.
Well, so here's like, think of it in English terms, I guess. So if I tell one of you guys, like, while there are cookies left in the box, eat a cookie, versus if there are cookies in the box, eat a cookie. What does that mean in like human terms? If I say do it, if I say if there are any cookies left in the box, eat one, you would look and see if there's cookies in the box and eat one. If I said while there are cookies left in the box, like eat a cookie. Right, you would keep doing it until the box was empty, right? So like, do this while some condition is true. So in other words, a while is, I don't know if we've used this terminology extensively, but a while is a loop, right? So while statements continue to repeat everything inside their indentation as long as that condition is true, with the exception of, all right, so this is probably something worth like getting into. I think we talked about this a little bit before, but this is probably worth doing again. So let's just do a very stupid example of this. Let's actually just stop this running right now. Where's my stop? Let's kill that. All right, let's just do this. Let's see. Old cookies equals cookies. Cookies equals 0. Cookies. This is like, there's no reason to do this in real programming. That's okay. All right. But let's debug this now. All right. So this is going to go, all right, so we've stopped it here. So what is this while loop doing again in 15? So it's going to loop while cookies are greater than 0, right? Everybody clear with that? It's going to keep doing that stuff? All right, so let's say we do this stuff. So cookies is, what, 26 right now, right? We got it down here. Now we're going to make a new variable, this time called old cookies, which is now also 26. But then okay, so the next line of code says cookies equals 0, right? Which is going to make our condition in line 15 false, right? Are we clear with that, right? Cookies will no longer be greater than 0. So what's going to happen after we run line 20?
I'm not gonna care. Just gonna keep going.
Why?
Because you haven't
It's
gone
not-
back to 15 yet.
Okay, right. So that's the key thing to keep in mind, because I think a lot of people, when they first start programming, forget this. It's not checking the while statement. So, like, a human being, I know we've said this before, but it's just worth reiterating. A human being, if I say, like, while, something is true, like, do this thing, a human being will kind of, like, continuously check in, and presumably as soon as the condition stops, they'll stop what they're doing without completing a cycle of instructions or whatever, right? But that's not what the computer does, right? The computer only checks the condition when the condition, when it loops back to the beginning of the while loop and then sees the conditioning, right? So if it passes this test right here in line 15, it's going to do everything in this chunk of code here, right? Because that is all within that while statement. And only at the end of that is it going to go back up to line 15 and check again, right? Yes.
If you replace on line 15, if you replace while with if, then would it only go through 15 through 24 once?
No.
Wait, what? 15? Where's the?
So if it was like if cookies is greater than 0.
Oh, sorry, 15 through 24 line numbers. I was like, what's the? I was thinking like cookie numbers or something. Okay. Yes. So that's the difference between while and if, right? If only happens once, right? It doesn't go, like, if is something that is checked, in line, like, you go through the line of code, if this, it does this stuff, not, it skips that. But unless that if is, now, in this case, it does do this if stuff more than once.
But because it's in a while.
Because it's inside a while, right? So, like, that's the other thing is, which we haven't talked about a ton yet, is this is called nesting, right? You can nest these things infinitely inside each other, right? So, like, you can put an if inside a while, you can put a while inside an if, you can put a while and a for and an if inside another while, or whatever, right? So you can, like, have these many layers deep, which we have not done anything that complex yet, but you could, right? Does that kind of make sense? So, like, once you're in a context, like once you're in this while loop context, you call that if statement, right? And you could have another while inside the while. You could have another if inside the if. Is that clear to everybody kind of how that could work? It's like a flow chart, right? So like each little chunk of the flow chart might be a kind of loopy thing where you kind of loop around a path, or it might be kind of a branching thing, like in a flow chart, an if would be like a branching thing. But, each little part of that flow chart could have any of the other parts inside of it, right? So a loop could have a loop inside of a loop, and so on. Okay. Any other questions about this before we try some stuff on paper?
Can you go
Yeah.
over the percentage sign again? I think I was here for that.
Okay, yeah. So the percentage sign, so the actual name for it is modulo or modulus. That's the name of that operator, just like plus, minus, divide, times, or whatever. But what it is it's the remainder operator. So it gives the remainder of thing 1 divided by thing 2. So like it divides cookies by 12, but it doesn't tell you what cookies divided by 12 is. It tells you what the like integer remainder is of cookies divided by 12, right? So like going back to the actual Python terminal, if we had like 5 modulo 3, what would the answer to that be? What's the remainder of 5 divided by 3? 2, right? Because so in other words, 3 goes into 5 once, right? 3 times 1 is 3, and then there's 2 left over. I know we're not used to thinking of like it's been like I think in 2nd grade is when we last did remainders as like a thing, and then usually we're just used to thinking of it in decimal terms, right? And again, that's different from like so if we did. Keep in mind that like Python's weird in the way it does division, right? So 5 divided by 3 will give us what? 1, right? Because 3 only goes into 5 one whole time, right? And we've told Python we're working with all integers here because we only expressed it as 5 and 3. Now if we told it 5.0 divided by 3, then we get what? 1.6 is forever. Yeah, okay, yeah. Right, because that's the actual answer. That's the precise decimal answer. So in other words, when you say like 5 divided by 3, that's one whole time, and then like, so 1, 2, 3, that's the 3 that you take out of 5, and then there's 2 left over, right? And that's 2 out of 3, which is that like 0.666667, right? So if we did like, let's see, like 9 modulo 6, for example, what would that give us? 3, right? Because it's 9 divided by 6 is 1, but right, there's 1 6 inside of 9. But you take out that 6 and you've got 3 left over, so the remainder is 3, right? Okay, so anyway, that modulo operator is not always, like sometimes it's useful as a mathematical thing. But a frequent way that you use it is something like this. In range. Let's do like 30. If I modulo 12 equals 0, now this will also bring, oops, oh no, what did I do?
You should put in semicolon.
Oh, that's right. Sorry, thank you. For I in range, if that, thanks. I mix and match my Python and MATLAB syntax. Okay, so why did this code do what it does? So I is going to loop up, so this is a for loop, right? And range 30 means all the numbers from 0, all the integers from 0 to 29. So we're going to do this 30 times, first where I is 0, then when I is 1, then when I is 2, etc. And why does it print out this?
The else statement is just, I think about it like otherwise.
Mm-hmm.
Like if not that, then this.
Right. Mm. The cookies both help and hurt the Socratic method. They give me a pause. Sometimes it's too long if the cookie's too chewy. Okay. Right. So we haven't really talked about else yet, at least this semester, but hopefully you can understand it intuitively, just what it means in English, right? Where it's like, if something is true, do this. Otherwise, like else, I mean, we don't say it as else that often in English, right? But, or else, do this, right? Now, it doesn't mean like you're threatening the computer, like do this or else. But effectively it means, right, like else means otherwise, right? So if I modulo 12 equals 0, we print doesn't, otherwise we print not a doesn't, right? So what that means, what's that? You're gonna.
Doesn't that mean divisible by 12 then? If it's
Right,
divisible by 12,
right.
print doesn't. If it's not, print not.
Right, because if something has a remainder of 0, it means it's divisible by that thing, right?
But
it's evenly divisible by that thing.
Between 0 and 29, there's only 2 numbers that should be divisible.
Well, where do we start counting?
0.
Right. Right, because in computer land, we usually start counting at 0. Right, and that was one thing I did want to point out, right? Because 0 is divisible by 12 by virtue of like, there's 0 anythings in 0. So the remainder of 0 divided by 12 is, the answer is 0, remainder 0, right? Because there's just nothing there. So yeah, so we go like 0 is quote unquote an even dozen, right? Then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Then at 12, we say dozen again, right? Because 12 modulo 12 is 0, right? So that makes the if statement true. But then every other time that the if statement is not true, we do the other thing, right? Which is print not a dozen. Does that kind of make sense to folks? All right.
Kind of have like a big picture question.
Sure. Oh, can you, one second. So
Yeah.
the upshot of the whole point of that example is, a very common thing that you use the modulo for is to like do something every like 12 times or every however many times, right? So like if I'm doing something in MATLAB, sometimes I have like something that, I have like a whole bunch of runs or a whole bunch of subjects or something, and I want to like print out an update, but I don't necessarily want to print it out to update like every 2 seconds when it finishes one operation. maybe I only want it to say like every 1,000 times it does like some mathematical operation, say like what % done it is, right? So like I might check if I'm doing something 10,000 times, I might say, all right, every 100 times, give me a little like progress bar update, right? But you don't need like a line of text printing to the screen every time. So that's a super common way I do this. Or lots of other reasons you might do this stuff, right? But like modulo is an easy way to check if you're, every 10 times or every 100 times or every 73 times or whatever. Okay.
Yeah, that was gonna be my question.
Okay.
What practical use is this? 'Cause I can't think of like an example when I care about like the remainder or something. I guess you can.
Well, I mean, it's a mathematical operator like any other, right? Like, so sometime, if you're doing like technical science type stuff, another reason that you might want it is, what's a good example? Well, okay, so let's say like, there's all kinds of like kind of trivial examples I could give. So let's say you've got like an experiment where people are doing like 10 blocks and there's like 5 trials in each block, and then they get a little break in between, right? But your trial number counter only goes like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right? So like if you want to know kind of what trial within each block the person's in, you could say like what's the remainder of the current trial number, divided by like whatever, how many blocks there are per trial, right? So like actually we have some of our MTurk stuff is like this, right? So you have to do 50 trials correctly to get credit, but you get a break every 10 correct trials. So if we wanted to like keep track of like where somebody is within this little block of trials, we could say like, all right, current trial modulo 10 gives us like, all right, they're on the 4th trial within this block, right? So it's when, it's usually when there's some kind of like nested structure to what you're doing, right? When there's some kind of hierarchy where there's like kind of an overall count, but there's also kind of like a count within, you know what I mean?
Yeah.
I don't know if that makes sense exactly.
Is it the same? Is this the same use in R?
I don't know if it's the same symbol in R. I actually forget, but it is an almost universal feature of programming languages to have this operator. Like in MATLAB, it's a function called mod. In C and JavaScript, it's the %sign. Another good way to put this, like this is more common in programming. We're like, all right, so here's an example. Let's see. Does anybody who knows more Python remember? I think it's like, I'm gonna have to do some guessing.
Isn't it import date time?
That's what I'm trying to remember is which one has the one called now. Oops. Oh wait, you know what it is? Datetime.datetime.now. Okay. But that's actually not what I want. Let's see if it's this. All right, I can't actually remember what it is. Here, I wanted the epoch time. The time. So the way your computer actually represents what time it is internally. Well, if you had to represent like what time it is in some kind of universal format, how would you do it, right? Now you could have a really complex structure with a bunch of like with like this, with the year, the month, the day, the hour, the minutes, the seconds, and I don't know, the other thing is probably like microseconds or something like that. Yeah, it is. Or I assume it is. But you could actually represent what time it is. Like time is just linear, right? Like there was the Big Bang, and then 13 billion years later, here we are, right? And there's no like hours and minutes and seconds and years and everything else are all like artificial divisions of time, right? Those are like human-based cycles. But time is just like going always. So you have the answer, Rafe, what the epoch time is?
They say daytime but UTC now.
But that gives like that representation. All right, doesn't matter. Anyway, the actual way your computer internally represents what time it is in number of seconds since January 1st, 1970 at midnight. That's just the time they designated was like the beginning of computer time. And if you want to have a date before that, you express it as negative seconds.
Is that why that iPhone
Yeah.
glitch?
Yeah.
What was the glitch? I forget, but probably,
If
yeah.
you set your time.
Oh,
if you
yeah,
set your
like,
date to a
correct.
specific thing, it literally
Yeah, that was
just
the date.
destroyed your phone.
That was the date.
Yes, so that's the date. And that's just like, because Unix came into existence sometime in the 70s, and they're like, all right, we'll start keeping time at like some arbitrary date in the past, which is January 1st, 1970. And that's like, then you get to represent all of time as like one single integer, or if you want like less than a second resolution, like a floating point, right? And then when you need to know, this is going to kill me. Like, all right, let's just quickly bring up a
There is something called import epic.
Python epic time seconds. This is going to kill me. Oh, it isn't. Maybe it is in the time library. All right, so you'll get to see this in just a second. Let's try GM time or local time. Time.gm time. It's all getting converted to years, months, and seconds. Let's see. Oh, seconds since the. Let's see.
Is it not GM?
No, let's see. That was so GM. To find out what the epoch is, GM time is 0. It's all these weird like documentation things. I have to figure out. No, that's not it. This is killing me. Killing me, Smalls. All right, calendar.timegs. This is like a very This is very ass backwards way of doing it, but we can do that if we have to. All right, so let's do it.
Someone posted an equation calculator.
Well, calendar.timegm looks like it'll do it. So let's see. Import calendar. Calendar.timegm. Time.gm time. Fine. All right. So it's been that many seconds since January 1st, 1970, right? If you wanted to know that. And let's see if we can prove it. That
Seconds?
should be seconds, yeah. So let's prove it. Well, first of all, let's do minutes, right? Because that's easy. So, and we'll forget about some of the details. So if we have that number and we want to know how many minutes that is, what do we do? Divide by 60, right? 60 seconds in a minute. So it's been this many minutes since January 1st, 1970. Now, how many minutes are there in a year? Somebody who has seen Rent. Bonus points if you sing it.
525,600.
Okay.
You didn't say.
No, it's wrong.
512,600. Oh, so it's going to be min divided by that, right? It's been 46 years, give or take, since January 1st, 1970, right? So that's, given some rounding error, that's correct, right?
You put a decimal after the 500.
So if we wanted to know more exactly, oops, 46.17 years.
Nice.
And now, here's an interesting question. How do we get the fractional part of year? So let's say we want to know how many months. So like, all right, so we know it's been 46 years now. This is screwing up with like leap years and odd seconds and stuff. But let's say we don't care about the years. We want to use this to calculate the date today, roughly speaking. So we know it's been 46.17 years. So 46 years, whatever, like that's January 1st, 2016, right? So that 0.17, blah, 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 how do we get just the fractional part out of year?
Percent.
Well, we could do it a bunch of ways, but let's see. We could actually just do that, right? So the remainder, so we haven't done the percent thing yet. So we haven't done the remainder thing with like non-integer stuff, right? But we just picked some numbers like, 6.2 ampersand 3. Well, this is your floating point math being imprecise. 6.2 remainder divided by 3 is 0.2, right? And 6.2 remainder divided by 1 is also 0.2. Now, don't worry about that 0.18 on the end. That's that whole thing about, like, I think we talked about this earlier, like floating point math is inherently imprecise because you have you remember we talked about floating points being decimals, right? So computer decimal representations are always imprecise. And there you're getting some kind of weird, like, rounding error that happens in Python. But approximately, in fact, exactly, in reality, the remainder of 6.2 divided by 1 is 0.2, right? Because the fractional part is the remainder when you divide something by 1. What?
I don't trust Python anymore.
It's not Python. This is like how all computers work.
I don't trust computers.
This is why. So this is why. Here's a question. Is 6.2 modulo 1 equal to 0.2?
Oh,
No.
I mean, is it in reality?
Yeah.
Yes. Is it going to say yes if I say do this? Now, so yes, this is where like life gets tricky if you ever work in MATLAB. Actually, MATLAB is good to you because when you test for equality, it implicitly interprets that is the difference between these two things less than like 10 to the minus 14th or something like that. But otherwise, you have to do something like this. Right. Because yeah, any decimal representation to a computer is intrinsically imprecise.
If you wanted to use those last two decimal places where you have the 1/8, you're kind of stuck.
Mm,
Or can you extend the decimal?
well, probably, I think we talked about floats and doubles. Like we definitely do in MATLAB.
Yeah.
So you can have like more bytes allocated to the
Oh,
representation, which gives you like more digits, which therefore gives, just like with scientific notation, if I tell you like you get 6 significant digits versus like 12 significant digits, you can represent more precision for the same kind of scale of magnitude with more digits.
So does that go from a double to
Well, so yes, there's no such thing as like a quadruple length floating
Yeah.
point number right now. I mean, you could like, in the future when we have 128-bit processors as opposed to 64 maybe, but you could always invent your own way of representing numbers that you could
Yeah.
code up. But in terms of like what's built into the computer, yeah, like whatever counts as a double length float is the most precise you can get. Now there are other ways, which we can talk about offline, to represent like fractional values. Remind me to tell you about fixed point later, but that's high level stuff. Actually, it's not that hard. Like you just basically designate like fixed point is basically like what we have. It's an easy way to say this. Okay, don't worry about it. It's more important things to talk about. We haven't even gotten to the paper exercise. Okay. The important thing being, those are some ways that you might use modulo, right? So like the number of years it's been since 1970 is like the number of seconds it's been since 1970, modulo the number of seconds in a year, right? So like anything that's kind of cyclical, you can get the kind of value in some cycle by, one of those subcycles by moduloing out everything else, right? So if we want to know how many seconds we were into the current month, well, we'd be screwed because like this is why time sucks, because months have different numbers of days in them depending on what month it is. But if we want to know like how many seconds we are into the current hour, we could take if we want to know how many seconds we are into the current minute, and what we know is the number of seconds it has been since the hour started, we could modulo 60, and that gives us like the number of seconds into the current minute, right? Does that make sense to people?
Mhm.
So if I tell you guys that it's been like, what has it roughly been? So let's say it's like 46 minutes and 30 seconds or something like that, times 60 plus 30. So let's say it's been like, let's say sex equals 2790, sex. If anyone has used like Psych Toolbox and MATLAB, there's functions called wait sex and get sex, which are like intrinsically funny. All right. Yeah, of course, yeah. Everybody loves sex. Okay, so if we wanted to recover that, right? So if we knew it's been 2,790 seconds since the hour started, if you want to get how many minutes it's been since the hour, what do? Sorry, that's a leading answer. Sex what gives you the number of minutes since the hour started, without worrying about how many seconds after the minute mark.
You use like some sort of the modulo to figure out the remainder.
Well, wait a minute. I think you're ahead of us. So if I say it's just been 2,790 seconds since like exactly 2 o'clock p.m., and I want to know how many minutes it's been,
Oh, okay.
then what?
Divide by 60.
Yeah, just divide by 60, right? And if we do that without floating point, it'll round off the fractional part, give us 46 minutes, which is what it was a couple of minutes ago, or a minute ago. And if I want to know how many seconds past the minute it is when we have 2790 seconds on the clock, then that's what? seconds modulo 60, right? Because, right, so if it was 46 minutes and 30 seconds past the hour, and that's 2,790 seconds, right? You divide by 60 to get how many minutes it's been. You modulo 60 because there's exactly 60 seconds in every minute. And so, like, in other words, that's like saying the clock, you know, it's like a clock, right? The clock finishes a cycle every 60 seconds, right? So, like, basically the modulo resets every time the clock hand hits 12, right? So you get the remainder of all the seconds divided by 60, and that's 30, right? That gives you 46 minutes and 30 seconds past the hour. Does that kind of make sense? All right, everybody know how to do time calculations now? Maybe. All right. So we're not going to get to much of the example that I mapped out, but that's okay. We'll get to some of it, and we'll finish up next time. So here's the problem I want us to think through. This is where, if we talked through last time, we talked a little bit about the idea of like the empathy for the machine and trying to like think like the computer, right? So if everyone does not have a sheet of paper, grab a sheet of paper and a pencil or pen of some sort. Let's see if this is anything important. These all should be scrap paper. That looks fine. So the idea here is like you won't always code. There's scrap there too, or pens and stuff. Yeah, by the cookies. Grab a cookie while you're at it. Okay. So basically the idea here is like you will not always plan out your programs on paper, but in theory, if you know what you're doing, you should be able to like write out the program on paper as well as you can on the computer, right? So I think it's a really good exercise to start like seeing how well you know this stuff to try to plan out your algorithm, right? Your plan for your competition, or to like work through what some code is doing on paper, right? So you can do this both ways. Like right now, I was going to do the thing where we pre-plan on paper and then try to turn that into code. And then the next step that we'll maybe try to do some of next time is look at some code on the screen and just using pencil and paper to be the computer, like work out what the computer would do with that, right? Because that's what's going to get you really kind of thinking in programming world, right? So what I'm saying here is like what we want to do with the paper is not necessarily like write Python code, but write a plan, like an outline for what we want to put into Python code. I don't think we've necessarily used the word pseudocode here, but that's what we call it basically. It's like, you don't have to say like, you know, you don't, in other words, if you want to like say, all right, what's our algorithm, what's our method for calculating like the number of minutes into the hour we are, you don't have to sit there and put like, you know, min divided by 60, although that's a pretty accurate human representation too. You could like write it out in human terms, like minutes variable divided by 60 or something like that, right? So that's what or what did I say? Seconds variable divided by 60 is what it should be, but you get the idea, right? So in other words, we're just gonna like try to map out a series of steps, and then maybe next time we'll try to turn that into code. Okay, so here's my problem that I want us to work through with our pencil and paper, which is using the concepts that you know a computer can do, like loops, variables, etc. Let's come up with a way to find all of the prime numbers less than or equal to 20 and print only the prime numbers out, okay? So we don't need to save them in any list or write them to a text file or anything crazy like that, but we just want to like go through all the numbers up to 20, decide if they're prime or not. I'm already kind of giving you a hint. And the ones that are prime, print them out, okay? So that's going to be 2, 3, 5, 7, and you can't just like write 2, 3, 5, 7, not, or 2, 3, 5, 7, 11, 13, because you know them. That does not count. So you can't pre-program knowledge into there. But it doesn't need to be efficient. It doesn't need to be like all that smart. It just needs to be correct, okay? So that is our job. Now, before you start writing, well, I mean, you can start writing, but let's think through it together. As a human being, assuming you knew what prime numbers were but didn't have them all memorized, what would you do? Like just let's brainstorm how you would start to do that process. And let's say we'll throw out 1 because 1 is special and it can be neither prime nor composite. But, so you're starting with 2. How do you generate this list? What is your thought process as a human computer for doing this?
We have to answer.
Yeah, so please answer.
I mean, first thing, go ahead. I was just gonna say I'd go through. Let's
starting with the first number and just do it that way.
Okay, so one part of it
Yes,
is,
no,
right.
yes, no.
So that probably makes sense, right, is to start with. So if I say I want the numbers 2 through 20 to be decided on, right, it makes sense to like count up from 2 to 20 and make a decision about each one in turn, right? So that's kind of our overarching strategy, which would be equivalent in like Python terms to what?
Count the range.
Yeah, it would be like a for loop through a range, right?
Yeah.
So in like pseudocode terms, why don't I write this out in like a text editor in pseudocode? So let me, then
Can
it
you or like when this isn't up, can you have the other thing up where we did the cookies example?
what's that? Oh, do you want to see the cookie code?
Yeah, 'cause I forget. What
Yeah, let me just switch to my text editor here and make a new text editor window. All right, so let's bring that over here and switch back to PyCharm and then back to that. All right, so we can move this over. We can see most of both of these at one time. Okay, so like we might say, come on, dude. I like that text editor, but it's got some annoying features. All right, so we can see most of most things. Okay, so we might say like, and again, I'm just going to write this out in text, right? So we might say something like, for the numbers 2 through 20. You know, so that's like not Python, but that is a humanish way of expressing kind of what Python would do with the for loop. And then like everything else is going to be kind of indented, right? Like here's going to be a series of bullet points or steps or something like that, just like you outline a paper or something like that, right? So, you know, this is the idea, right? This is like, you know, computer programs are kind of meant to look sort of like human. Like if you outline a paper, right, you have like sections and subsections and sub-subsections. So indentation is kind of the same idea, right? All right, so within the general overarching strategy of checking each number 2 through 20 for its primeness, so like let's just pick a random number like 8 or something midway through the process. How would you decide if that is prime or not prime using basic mathematical tools at your disposal?
You just so I guess I try to think about it. It's being syntax. I don't know if like and words here. Basically, you need 2 logic statements. You need is it divisible by 2, and is it wait no. Or
Let's
is
pick
it-
a harder one. Let's pick like 18 or 15 or any one of those. So like, how do you decide if, or let's say like, let's actually make it one of the prime ones. Let's say 17. So you're trying to decide if 17 is prime or not. What do you have to be doing to be sure that 17 is prime?
Divided by every number and lower.
Every number what?
and lower.
Every number and lower. And so
Every number, okay, then itself. Not every number in existence, but like, yes. So every number from starting with what?
it's on drawing.
All right, I mean, so 17 divided by 17, do we check that?
Oh right, it has to be
Because that's an
it
integer.
has to be minus.
All right. So everything up to the number -1, starting at the bottom where?
Sorry.
Two.
Can you do like modulo range?
Okay,
To
well,
check something?
so right now we get our first like kind of monkey wrench in the works, right? Because I think what we're saying is if you want to check through to see if 17 is prime, you really have to check every number from 2 through 16 to see if those divide into 17 evenly, right? And if any of them do, it's not prime. But if you want to check 13, you only have to check 2 through, I mean, you could, I guess, check up through 20 because like no smaller number is going to be evenly divisible by a larger number until you get to 2 times that number, I guess, at which point like it sort of is because it goes in 0 times. But yeah, presumably if you were checking 13, you want to check 2 through 12 to see if those divide evenly into 13. So you're saying like, how do you do that with different ranges for different numbers, basically? All right, so how do we do that? How would we express that inside of our for loop? Like, so let's say the number that we're currently working on is 13. What we
I think it's probably that. I'm probably wrong, but I think you would have like 2 range statements. one would be like the numbers that you're checking, and the other one would be like that minus 1, and then you check for like if there's a remainder.
So, right, so the basic idea is we want to check and see if there's any remainder when we divide, right? So I think what you're saying, so what would I like write in sort of human outline form here in terms of like what's our next kind of structural element under the big for loop? Like, so if I say, all right, we're in the overarching sense, we're going to loop through the numbers 2 through 20 and check and see if each one is prime. When I'm on each number, let's just pick one, say like 13. What is my kind of organization or my next kind of level in? So we said I need to check 2 through like 12 if I'm checking 13, right?
You need another 4 to 12.
Okay, right. And so we could say something like for the numbers 2 through what?
I minus 1.
Yeah, like whatever our current value we're checking is minus 1. Does that kind of make sense to everyone? So if we're checking 13, we want to check 2 through 12. If we're checking 17, we can check 2 through 16. Now there's one minor caveat, which we can deal with in the real code, which we'll have to figure out, which is the number 2, which is prime, which is going to be a little weird because we are explicitly starting with 2 and all this, but we'll worry about that later.
You just, it's probably really inefficient, but my guess would be that you just explicitly state like a line that 2 is prime. Like 2.
You could, but that's lame. That's like no fun.
That's what I figured.
Yeah, you could. It's actually going to work out more nicely than you would think, but for maybe not clear reasons if you haven't done a ton of this. All right, so let's not worry about 2 right now. 2 is weird, but 2 will take care of itself. Mostly. So what do we do now kind of inside? Well, let's see what time it is. Oh, it's 3 o'clock. So maybe ponder for the next week or so.
No.
Yeah, so maybe ponder for next week. Before we go, there's one other thing I wanted to check, which I've been meaning to check forever. Jeff was asking about, so we were planning on doing R in the later part of this. Let me just check and see. Jeff just had some minor tweaks to the dates, if I can find them real quick. But I guess I should say, is anybody aware of like in that approximate date range that we were talking about for our dates, which is I think it was like the 3 or 4 weeks after spring break. Does anybody have any major like commitments or issues in those weeks that they can think of on a Monday? It would be like I think we were going to do it the 3 weeks, the 3 Mondays right after spring break, so I can actually tell you. Actually, I might have them. I do have my calendar app up. Let me see if I've got it here. So let's see. Spring break starts on. So we didn't have one on 3/21, and then right. So we were going to think about doing it on like 3/28, April 4th, and April 11th. But Jeff is busy on April 11th. So would people be okay taking the 11th off and doing it on the 18th instead? Anybody foresee problems with that? Okay, and we could even not take the 11th off and go back to Python for a day and then come back for an R and just not have a break or something. But all right, so nobody has any issues with the 18th because that would be like that would have been our off day on our like 3 on 1 off cycle. But we'll just plan to meet on the 18th. Okay, cool. So I'll send that out. Make sure nobody else has an issue with it. But let's plan on that for now. All right. So good programming meeting, everyone. Mull over what you might do about that prime checking algorithm in the next week or so, and we'll get back to it in a week.